mean, we've gone to all of the efforts to purify these materials. The next step in the process, and in fact the ones where things can go the most wrong, is in the assembly. There are two ways that things can go wrong background-wise in the assembly. One is by exposure to radon and dust and all of the ways that radioactive contaminants can be carried by air. We can mitigate that two ways. We can do the work in a clean room, which controls the dust-borne radioactivity. This is things like uranium, thorium, potassium, carried on particles of dust. We can store the parts in a non-air environment, so perhaps in storage containers that are purged with nitrogen or argon gas, and we do that. That can control things like radon, which is a radioactive gas. It comes out of the ground due to the natural decay of uranium and thorium, and it can decay and deposit radioactive daughter particles on our materials. And then when those materials are put together into a detector, we would see those sources of radioactivity if we didn't take steps to mitigate them during the assembly process. Being able to do the assembly process, which can sometimes take weeks or months to put a new detector together, in some cases even a year or more, by doing that in a shallow underground lab, we're protecting that material from exposure to high-energy neutrons to a great degree. The high-energy neutron flux in our shallow lab is only about 1/100th of what we see on the surface. And so 100 days of assembly there are like 1 day of assembly in a typical laboratory on the surface. And so controlling the environment so that we're not building contaminants into the detectors, and then using the depth to control the rate at which radioactive elements are being created in the material are the two ways that the lab and it being a clean room work together to let the detector assembly happen and let us meet our background goals.